So for this week, we're going to start by adding and subtracting fractions with different denominators, just reviewing that skill. Then on Tuesday, we're going to look at adding mixed number fractions. Wednesday, we're looking at circles, properties of a circle, and on Thursday or Friday, it's Mathletics or Genius Maths. So welcome to our first lesson back after half term. In our maths lesson today, we're going to be adding pairs of fractions with different denominators. So mild, you're going to be adding simple fractions with different denominators by converting. And spicy, you're going to be adding any two fractions with different denominators by converting, including using division to convert. And hot, you're going to be adding fractions, converting confidently between different denominators, as well as mixed and improper fractions. So to add fractions with the same denominator, this is really simple. We simply need to add the numerator. So because in this case we're working with thirds, we know that we're going to have thirds in our answer. So it's going to be 2/3 add 2/3 gives us 4/3, which actually means 4 divided by 3. So how many 3's can get into 4? It's 1 whole and then 1/3 left over. To visualise this, I can draw a bar model divided into 3 equal parts because we're looking at thirds. And I know that I'm actually going to have more than just 3/3, so I can colour in my thirds. 1, 2, 3, 4. So I've got 4/3, which means in total I have 1 whole and then 1/3 left over. Now I'm going to look at adding fractions with different denominators. We've got quarters and eighths here. So I actually can convert just the quarters into eighths. We'll leave the 3/8 the same, and we're going to convert the 2 quarters into eighths. So what have we done to the quarters to make it eighths? We've actually multiplied that by 2. And we do the same to the numerator. So 2 times 2 is 4. That gives us 4/8 add 3/8, which makes 7/8. Now that it's the same denominator, we can simply add the numerators. So the answer is 7/8. So here is another example of adding fractions with different denominators. We're going to need to convert them to the same denominator. So we need to find a common multiple of 5 and 4. So the easiest way to do that is multiply the numbers together. 5 times 4 is 20. So I'm going to make both of my denominators 20. And I'll be adding them. So I need to think, what have I done to my denominator to make it 20? I've multiplied that by 4. And on the other side, I've multiplied that by 5. So do the same to the numerators. 1 times 4 is 4, and 3 times 5 is 15. And we're going to add those together, which is 19/20. We can't simplify that any further because 19 is a prime number. Okay, so we're looking at how to convert from an improper fraction to a mixed number fraction. Remember, an improper fraction is a fraction where the numerator is greater than the denominator. So in this case, 7/6, we know that it's greater than a whole. Before we do anything, we have to think to ourselves, what is a whole in terms of sixths? Well, a whole pizza, you know how I like my pizza. If we cut a pizza into 6 slices, we are going to have a whole pizza is 6/6. So we've actually got 7/6 here. So we're using a hexagon to represent the pizza, but we've got 6/6 making up the whole, and then we've got one more on top, which makes 7/6. But in fact, it's actually just 1 whole and 1/6 on top. So 7/6 is the same as 1 1/6. And we have to remember how this works. So 6/6 and 1/6 combined together makes 7/6. So 7/6 is equivalent to 1 and 1/6. The handy tip is just to say, what is 7 divided by 6? So 7 divided by 6 is 1 with 1 left over. So there's 1 whole 6 and then 1/6 left over. So in this case, we've got to change 13/6 to a mixed number. So from the improper to a mixed number. So we're going to take 13 and we're going to divide it by 6. So how many 6s can we get into 13? Or in other words, how many full pizzas can we get if we're cutting them into 6s? So we've got 6 and then 12. So 2 times 6 gives us 12. We can get 2 lots of 6 into 13 with a remainder of 1. So 2, it's 2 whole pizzas and then 1/6 left over. So we make sure that the 2 is the whole number and the remainder just is the numerator for the new fraction. So the answer is 2 and 1/6. You can always draw a picture to help you represent it like the hexagons on the previous slide. So we've got to change 3 and 5/6 to an improper fraction. So again, drawing a picture might help you here, but remember that what we've got there is 3 whole pizzas cut into 6 pieces. Remember, it's sixths, so we're looking at 6 pieces per pizza. And then, so we've got 3 whole pizzas and we've got 5 additional slices. So the first thing to do is multiply the whole number by the denominator. So 3 times 6, because that tells us how many slices are made up from the whole pizzas. So we've got 3 times 6 is 18. So that's 18 slices from the 3 whole pizzas. 3 times 6 is 18. And then we simply need to add the 5. So 18 add 5 gives me 23. So what I've actually got is 23 pieces, 23/6. And if you want to check it, you can go backwards, use the inverse. So you can say 23 divided by 6. Well, 23 divided by 6 is actually going to be 3, remainder 5. And then that just comes back to the skill that we just learned.
Right, year 6, I've got my notebook here again. I'm just going to go through those skills briefly for you again. So we're going to start with improper fraction to mixed. So we're starting with 6 quarters. So 6 quarters. We're thinking about pizza again. We've got 4 slices per pizza. So the step is 6 divided by 4. Remember that this fraction line actually means divided by. 6 divided by 4. So how many 4s go into 6? Well, it's 1 whole and the remainder of 2. So it should be 1 and 2 quarters. We can check that in a minute by following the mixed to improper steps. So 1 whole pizza and 2 quarters. So the next one, 4/3. So 4 divided by 3. How many 3s can we get into 4? If we've got a pizza and we're going to split it into 3 pieces, we know that we've got thirds here. 1, 2, 3 thirds is a whole pizza, and then we've got 1 on top of that. So how many 3s go into 4 is 1 and the remainder of 1 extra third left over, 1 and 1/3. Next one, how many 2s go into 5? So it's going to be 2 times 2 is 4. So 2 2s and 1 left over, 2.5. Moving on to mixed to improper. So the steps here is whole number times the denominator. Then we add the numerator, and that gives us our new numerator. So 1 times 3 is 3. Add the 2 is 5, and it's always going to be thirds. If you want to, you can write the denominator first. So in this case, 2 and 4/5, it's always going to be fifths as our answer. And this one is going to be sevenths. 2 and 3/7 is going to be some kind of amount of sevenths. Okay, so just to recap the step, whole number multiplied by the denominator, add the numerator. 1 times 3 is 3, add 2 is 5, so it's 5 thirds. 2 times 5 is 10, add the 4 is 14, 14 fifths. 2 times 7 is 14, add the 3 is going to be 17 sevenths. And like I said earlier, we can check this by just going back and doing the reverse. So how many 3's go into 5? It is 1 remainder 2. So we've got 1 remainder 2. How many 5's go into 14? 2 remainder 4. How many 7's go into 17? It's 2 remainder 3.
So there are some fraction tasks for today to complete, and then later in the lesson there is a game for you to carry out. So the tasks are on the next slides, and then after you finish the task, if you've got time, you can go and try the game. So for this game, for the rest of the session today, you need to go to Google and type in fruit splat fractions. And it's this first link in here. So, okay, you've got different choices of level. You can start with adding fractions with the same denominator, and then level 1B asks you to simplify those. This is also with the same denominator, but 3 of them, and then simplify. But I'm going to start with level 3A, which is adding fractions with different denominators. I'm going to go straight to timed mode, and I'm going to click fast fruit. I guess that's the harder one. Okay, answer as quickly and correctly as you can to increase your score. So my question is, a half add 4 sixths, so I'm going to convert the half to sixths in my head or on paper if I want to. So a half converting to sixths is timesing by 3. So we're going to multiply the top by 3, that's 3 sixths, add 4 sixths is 7 sixths. It's 1 and 1 sixth, isn't it really? That was an improper fraction. A quarter add 2 eighths, so a quarter is equivalent to 2 eighths actually, so 4 eighths, which is a half. A quarter add 3 twelfths, so converting the quarters to twelfths, I'm multiplying by 3, so it'll be 3 twelfths, add 3 twelfths is 6 twelfths, or a half. Thirds and tenths, I'm going to convert both of these to 30ths, so that's 10 30ths, and multiply that by 3, 15 30ths, 25 30ths. You might need to use paper for this, I'm just doing it in my head. Halves and fifths, so tenths, so I've got 5 tenths, add 4 tenths is 9 tenths. I don't know if the time stops at any point, but I'm going to just stop there, so you get the idea. So for day 2's lesson, we're going to be adding pairs of mixed number fractions. For mild, you're going to be adding mixed number fractions, but only with the same denominators. So you might need to be able to convert from improper to mixed, but you'll be sticking with the same denominator of fraction. For spicy, you'll be adding mixed number fractions with different denominators by converting. And for hot, you'll be adding and subtracting with mixed number fractions. So we're going to look today at adding mixed number fractions, starting with fractions with the same denominator. So we've got 1/3, add 2 and 2/3. So there's a couple of steps here. When you're adding, you can just combine the whole numbers first. So we're going to start with 1, add our 2. I'm going to just look at our whole numbers first. So 1 add 2 gives me 3 wholes. Next, we're going to add our fractions, so our 1/3 and our 2/3. Because it's the same denominator, it will be 3/3. And remember, if we draw a bar model, 3/3 is 1 whole. Now we just need to combine the 3 wholes and the 1 whole together, which makes 4 wholes. So the answer is 4. So that method works really well for adding. We're going to move on to looking at what you do when you have a fraction with a different denominator. So to add mixed number fractions with a different denominator, the method is very similar. When you're adding, and remember this doesn't really work with subtracting, so it only works for adding. When you're adding, you can combine the whole numbers first. So here we'll have 2 wholes and then 3 wholes. That will give us 5. And then you simply need to add the fractions, which we actually looked at yesterday. So here we're going to need to convert to a common denominator of 40. Remember, we're adding them. So we multiply this by 8 and this side by 5. So 3 times 8 is 24. 4 times 5 is 20. Now it's the same denominator, we can simply add 44 40ths, which here we need to think actually how many 40s go into 44. It's 1 whole with 4 left over. So we're not finished there. We need to add our 5 from the first step to our 1 and 4 40ths, which gives us 6 and 4 40ths, but we can simplify this further. The 6 stays the same, and we can divide the numerator and the denominator by 4. 4 divided by 4 gives me 1, and 40 divided by 4 gives me 10. So in summary, the steps are combine the whole numbers, add the fractions. You might need to convert to a common denominator. If you've got an improper fraction, like in this example, 44 over 40, you will need to convert that back to a mixed number and then recombine them. So moving on now to subtracting. This is more like the hot level, but Spicy Plus and Spicy, we have gone over this in class, but you can give it a good go. Remember, you can watch the explanation as many times as you like. So with subtracting, we can't simply subtract the whole numbers from each other and then the fractions from each other. It doesn't work that way. We have to split the 2 1/5. So we're going to start with 3 7/8, and we're just going to take away the 2, which actually just leaves us with 1 7/8. Now you've got a much more simple calculation to complete. 1 7/8 take away 1/5. So the 1 will stay the same, and we're going to convert the 8ths and the 5ths to 40ths. So we're going to multiply that by 5 and multiply that side by 8. 7 times 5 is 35, and 1 times 8 is 8. And now that they're the same denominator, we can subtract them. 1 35 40ths take away 8 40ths is 1 27 40ths. So that's our answer. So it's different with subtraction to the addition method because you have to start with the first mixed number, the biggest mixed number, and take away the whole number, and then you've got a more simple calculation. An alternative method that we have spoken about before Year 6 is where you convert both of the mixed number fractions to an improper fraction first, using the method we looked at on Monday, and then once you've got an improper fraction, you then can subtract just using the improper fraction. So I'll quickly show you that on the screen so that makes sense, but either of these methods will be absolutely fine for you to use. You just choose which one you prefer. So here's the explanation I just spoke about. We can use this method, but I think the previous method is quicker. But if you are more comfortable with this one, that's fine. This method is where you convert the mixed numbers to an improper fraction, and then you might need to convert them to the same denominator. So 3 7/8, 3 times 8 plus 7 is 24 plus 7 is 31. So 31 eighths is the first fraction as an improper fraction, and then 2 1/5 to convert that to an improper fraction. 2 times 5, remember the whole number, times the denominator, that's 10, add the 1 is 11, 11/5. So now we've got 31/8, take away 11/5. We can't work with eighths and fifths, so we convert them to 40ths. So we're multiplying the eighths by 5 and the fifths by 8. So it is 31 times 5, which is 155 over 40. And then 11/5 becomes 88/40 because we're multiplying that 11 by 8. So now the calculation says 155/40, take away 88/40, which gives us 67/40, which is in turn an improper fraction. So just for convention, we need to put that back as a mixed number fraction. So convert that. How many 40s go into 67 is 1 whole 40 with 27 left over. So that is the same answer as the previous slide. I think this method is a little bit longer, more time consuming, but it avoids the issue of accidentally making the mistake of subtracting the fraction in the wrong order. There are some issues with the previous method, so it's really up to you. I would suggest if you're confused, watch both methods again and then give it a go if you're in hot group. The subtraction problems, I think, only come up in the hot task, okay? So we're going to review the main parts of a circle and review the link between the diameter and the radius. So today we're going to use a clip from the Oak Academy, which comes from the Year 6 section, Maths, under the topic Coordinates and Shapes, and it's lesson 4 from that week. So we're going to start with a practical task, so you will need a piece of string and a pencil if you have got access to a piece of string, or a circular object.
So here's our first new piece of key vocabulary. So we're looking at the boundary of the circle. The boundary of the circle, as we just said, is equidistant from the centre, which means it is an equal distance from the centre all the way round. And the boundary of the circle, so the distance all the way round, is called the circumference. So you can either use one of the circles that you have drawn, or on a separate piece of paper draw around the circular object that you've brought to the lesson so that you have a perfect circle, and label the circumference on your circle so that you have it to use for later. Now the word circumference, it has the root word, which is a Latin word, circ, which means ring, and the prefix circum, which means around. It's always good to have an idea of where these words come from because they usually give us a clue as to what the words mean. So now, if I were to measure the circumference of a circle, how do you think I could go about doing that? So the best way to measure the circumference of a circle is to use a piece of string and a ruler. So if you place the piece of string all the way around the circumference of your circle, and then you take the piece of string and measure it against the ruler, you will see the measurement of all the way around the boundary, and you might need another person to help you hold the piece of string in place. So pause the video now and have a go at using a piece of string and a ruler to measure the circumference of the circles you have drawn. Great work. Let's look at our next part of the circle. So I have a circle drawn below, and these lines are examples of the radius of a circle. So have a think, how do you think you could define the radius of a circle? So here we have a diagram that shows us what this actually means. So this is the radius, this pink arrow is showing us the part of the circle called the radius, and it goes from the centre of the circle to the boundary. The radius is the distance from the centre of the circle out to the boundary. And remember that this distance is the same all the way around the circle. So all of these lines on this circle are the same length because the boundary of the circle is equidistant from the centre of the circle. And the word radius, this comes from the Latin radius, which means ray, but it also means the spoke of a chariot wheel. So the spoke is this line here on the chariot wheel, and that goes from the centre of the wheel out to the boundary. So now you can add this label onto your labelled circle that you drew before, where you wrote on the circumference as well. So how do you think you would construct a circle with a radius of 5 centimetres? How would you make sure that this radius was 5 centimetres? So you would use your piece of string, and you would need to measure the piece of string so that it's 5 centimetres from the centre to the pencil, and that will give you a circle with a radius of 5 centimetres. So what you could do now is have a practice of constructing circles with different length radius. So measure the string so that you know the distance from the centre to the boundary, and construct circles with different radius sizes. Okay, let's move on to our next part of the circle. These lines on this circle are all examples of the diameter of a circle. So how would we define the diameter of a circle? Well, here it is on our labelled diagram. So the diameter is the distance from boundary to boundary, but it's very important, this part, it must go through the centre. So I can draw a line from boundary to boundary there, but that is not an example of the diameter because it doesn't go through the centre point. It has to go through the centre. And diameter is derived from the Greek diametros, which means diameter of a circle, and from the word dia, which means across or through, and metron, which means measurement. So it's the measurement across the circle through the centre point. So add that now onto your label diagram so that you have got this image to go back and look at to help you with your questions later on. So now let's have a look at the relationship between the diameter and the radius. So we can see that if the diameter goes from boundary to boundary through the centre, and the radius goes from centre to boundary, we can see that the diameter is double the length of the radius. So the diameter is the radius times 2. And therefore we can use the inverse to say that the radius is half of the diameter, so the radius is the diameter divided by 2. So these are very important rules to remember. So remember that the radius is half of the diameter. if the radius is 3 centimeters, what is the length of the diameter? So I want to work out the diameter, so I know that diameter equals radius times 2, and I know that the radius here is 3 centimeters, so 3